Welcome. I think this is lecture 7, I think. I don't remember now. Centroid G for a triangle. Today is part 3. See, case 1. Triangle in general. Already over. So, just a recap. But I wrote a big recap. There's a reason for it. So, see, this I have been explaining since past 2 classes very thoroughly. See now, I won't explain much because once I finish case 2, that is, case 2 is, this is vertex, Nisha. This is vertex. Case 2 is isosceles triangle. Case 2. After case 1, case 2. Once I finish isosceles triangle, I will consider right angle triangle, case 3. Then I will consider trapezium. Today only I will try trapezium. Once I finish trapezium, today's class will be over. I will derive expression for centroid, location of centroid for trapezium. Next class will be a final summary class for both triangle and trapezium, where I will give some extra information regarding that loading also, because very important. Okay, start now. Already I told you, triangle in general means if you call this is the base, this is the height. See, there is no base this way. One this way can be base, and this is the height. Then centroid will be along the height. See, we measured from the base along the height 1/3 h, or from the vertex towards the base, if you measure 2/3 h. Anyway, you can make out because more area is this side. So, but remember, suppose the same triangle is this way, then see, centroid will be here. This all I will explain in the summary class, next class. Okay. 1/3, 2/3, already over. So, I told you already 1/3, 2/3 is to be used only along the height. See, there is some divide by, this is not that 1/3. See, this I never call 1/3. This I will call b plus b1/3. See here, this I will call b plus b1 full divided by 3. I will never use the word 1/3 here. See, so therefore, remember, 1/3 or 2/3, make a big note. The term 1/3 or 2/3 we are using only when you locate the centroid along the height. This I told you last time, sufficient. Furthermore, if I tell, some will tell he is wasting time telling same thing again and again. Okay, leave it. Now, this will give location of centroid along the height. What about along the base? Last time we proved it. See, centroid will be here. See, this is, imagine base D, this length, see, this point here. This is light line, come here. Don't jump, don't come. See. This is B1, this is B2. I have taken B2 little more than B1. There is no rule that B2 more than B1, B1 more than B2. This all I will explain next class. So right now, one of them is B1, other is B2. Anyone can be more. See, here I took B1 more. Then centroid along the base this way will be on that side where area is more. See here, lesser area, more area, centroid will come here. Suppose by chance I took this way, see, centroid will be, then centroid will be this side. These all explanation in the next class. You remember one thing, along the base, see, if you drop a perpendicular from vertex, the base you can divide into 2 parts. One side B1, one side B2. So centroid along the base will be, if you want to measure from this side, it is full base, this all statement I will give you next time, full base B plus this side distance B1 divided by 3. Here, see, full base B plus this side distance B2 divided by 3. Or I will tell you in words here, if I stand here along the base, full base plus where you are standing, that side cut base. I will use the word cut base. Someone will tell what is cut base. my student understand me sufficient. Suppose my students, if they understand, it is sufficient for me. I am not here to may please other people who want to comment actually. So I will tell, see from here, full base plus this cut base divided by 3 here. Full base plus cut base divided by 3. This we proved last time. Now, or if the triangle is this way, see, once again, triangle in general. Now, this is the base, this is the height. Shall I write here? Okay, this is the height, because why? Height. Here, see, for this base, height defined. There is no base here. Here. This way, there is no base. So, this way, base is there. So, if this is the base, this is the height. So, along height, 1 by 3, 2 by 3, already over thousands of times. Along the base here, see, centroid will be, see, in this sketch, I took B1 little more than B2. Okay, no problem. So, centroid will be here. So, from here, if you want, full base B plus this distance B1 divided by 3. From here, full base plus that distance divided by 3. Very thoroughly explained, sufficient, because next class is meant for thorough explanation. Okay, now come to case 2. Isosceles triangle. Remember, if isosceles triangle is there, see, earlier we called this as B1. Call B1. This we called B2. B2. Both will be equal to B by 2. Why? Isosceles triangle means this angle equal to this angle and these two are equal. Don't see red color now. Don't see red color. See, full base B, height H, as usual, along the height 1 by 3, 2 by 3, I don't want to waste the time. Along the base where, see here, suppose you substitute here in this formula, B plus B1 by 3, your X bar from here will become, see, B, see, this is called X bar from this side. It is actually little, the board is little wet, that's why ink is not coming out. Okay, okay. Now, see, from here, if you locate X bar from here, the formula is what? B plus B1 by 3. Full base B, cut base is B by 2 divided by 3, or B plus B by 2 is 3 by 2B divided by 3. 3 will cancel, it will become B by 2. Same way, if I locate X bar from here, that also will come equal to X bar from here. That also will come equal to B by 2. Or, see here, if B1 is not equal to B2, this way centroid will shift to one side. You have to locate here also. When B1, B2 are not equal, centroid will shift on one side. You have to locate. But here, both are equal, so centroid will be exactly at this point. So if I project, see, this red color B by 2 is for G. If this is B by 2, this is B by 2, this is centroid also at B by 2. Or there is one more rule is there. I will tell you now. See, make a note. I will put it later. In case of symmetry, if there is an axis of symmetry, then centroid lies in the axis of symmetry. So make a note. This all I will tell you later. If there is an axis of symmetry, then centroid lies in the axis of symmetry. That means, see, I'll put here now, that case. See, this way and, okay, I'll do one thing now. I can remove this one now. So I can show you clearly here. Instead of that way, it is better to show this side because this I can remove now. This is already over so many times. See. Or you can do one thing, see here. That you can write a rule here. See, make a note. Make a note. If there is an axis of symmetry, then centroid will lie in that axis of symmetry. Axis of symmetry. Common. Therefore, same sketch if you see here now, see, this way, and this way. See here. This is B. Half of is B by 2, B by 2. B by 2, B by 2. Isosceles triangle. B by 2, B by 2. Therefore, one thing guaranteed, see, this is axis of symmetry. See here. This is axis of symmetry. I write here. Axis of symmetry. Don't write AOS, you write correctly. Axis of symmetry. Axis of symmetry. So, centroid lies in this axis where you know height wise it is here. See, width wise center. So, this will be 1 by 3 of H. This is H actually. I forgot to write H here. So, this is H. This will be 2 by 3 of H. Okay, this way you have to locate, but this way, center, see, once you locate 1 by 3H from here, the point comes here. There is no distance here, so this distance will be B by 2. This distance also will be B by 2, exact center. That is isosceles triangle over. Now, you take one more case of isosceles triangle. Or, you write once again, or suppose your triangle is like this. See here. This way. This is the base B. Base B. Out of scale, this is height H. Right here. H is the height because this is the base. Base. These distances are equal because isosceles triangle, these angles are equal. This will be B by 2, this also B by 2. Now, this is your axis of symmetry. See here, this is your axis of symmetry. Centroid lies here. Where lies? Somewhere here. See, as I told earlier, centroid G, height along the height it is 1 by 3H. From here it will be 2 by 3H. By looking only you can make out 2 by 3H. But this way, this will be B by 2, same distance. B by 2, this also is B by 2. Okay, I think it will be crystal clear now. Axis of symmetry is there. Or if you substitute B1 equal to B2, you get B by 3. B1 equal to B2 equal to B by 2. You will get X, Y bar once again will come equal to B by 2. Okay. Now, come to case 3. See, very powerful. Case 3. Case 3. That is right angle triangle. Right angle triangle. That is the most important for structural engineering. For structural engineering, right angle triangle is the most important for structural engineering among the 3 cases. Okay, now I will not call base and height now. What I will do is I will put a right angle triangle randomly. See, consider right angle triangle here. Consider a right angle triangle ABC. Okay, ABC. See, this way. You can see either you can take this way, or you can take this way, or you can take this way, or you can take this way. One of the way you take it. That all we'll discuss later. Here, which side I never tell that right side, left side like that. See, right angle triangle. I will tell ABC. I will call ABC. Say anything ABC. Don't write vertex now. Let this be X naught. See, the horizontal length is X naught. I won't call base and height. I will call that as x naught. Why x naught? Some x distance. This I will call y naught. Y naught. Okay. Now, for this right angle triangle, see here. Where is centroid? See. I want both distance of centroid. See. Now, right here. I want x bar. I already told what is x bar. I won't waste time telling again and again. X bar is horizontal distance. Okay. This is the triangle. This is x naught. X naught. This is your y naught. Okay, where is the space? I will do one thing. Okay, I will put here. Space required. Y naught. Y naught. Now, when you want x bar, see this way, you see that it is along the height. Therefore, you call y naught as the base B. X naught as height h. What you do? You stand here. See, this way you stand here. This is the base, this is the height, because this is perpendicular to this one, 90 degrees. See, this liberty is not there for triangle in general and isosceles triangle, where only one direction base is there, whereas both direction base are not there. Now, in that case, if you call this as height h, then along the height, I told you, centroid will be here. See, centroid G. This will become base for you. See, this is what? This is B, this is C, this is A. Now, if that is the base, this A will become vertex. Then, if this is the base measured along the height, this distance, see, small, it is, area is more this side, or from the base, it is from the base measured along the height, this distance is 1/3 of x naught. And this distance is 2/3 of x naught over. This is your x bar. Okay, now, this I am not required, space wasted here, see. This is y naught. This y naught, you take base. Or, no, to get y bar, see. How to get y bar? Once again, consider same triangle, see. A, B, C. This is your x naught. X naught is my choice. This is your y naught. See here, y naught. I will put right here for some reason. I am pushing outside, y naught. Now, x naught you take base. Base B. Base means B. Height is h. X naught you take base B. Y naught you take height. Height h. Yes, once again correct. See, if this is the base, this is the height, perpendicular. If this is the base, this is the height, then along the height, centroid will be here. See, along the height, centroid is here, G. From here, along the height, this is your x bar from C. This is your x bar from A. This is your x bar from B. Here, this is your y bar from B, equal to 1/3 of h. This is your y bar from C, because now C becomes vertex. C becomes vertex. Y bar from C, vertex C. This will be equal to 2/3 of h. Okay, this is, see, very simple. Once again, I will tell once again later. This is how to locate centroid for a right angle triangle. Now I will club both of them and write single answer. See, most critical answer. I will not use base and height. See, later I may use base and height, but right now I don't use base and height for understanding. Right angle triangle, see, right angle triangle, big sketch. Final answer. See, this is the final conclusion right here. This is x naught. This is y naught. Y naught because vertically I am marking. Don't call ABCD now. No ABCD. Okay, now vertex or nothing. See here. If you take this is the base, see, I'll put ABC. Okay, I'll put ABC. You should write a statement here. If I take AB as the base, x naught becomes base, y naught becomes height. So centroid will be here. See, divide the y naught into 3 equal parts. It will be here. See, centroid is here. G. How much distance? From here to here will be 1/3 of y naught. From here to here will be 2/3 of y naught. Okay, over. Because if this is the base, y naught becomes height along the height. Now, if you take this as the base, this will become height. So therefore, when you take y naught base along x naught, centroid will be, see, this distance from the base RCAC. Centroid will lie on that side where area is more area this side. This is 1/3 of x naught. This out of scale slightly. This is 2/3 of x naught. That's how you locate centroid for right angle triangle. I will stop because next class there will be a very thorough explanation. I will tell you why. I will write it. Ultimate explanation. Later in structural engineering all, I will tell whenever you got difficulty, you go to engineering mechanics class, some title I will write. I will write a title, some important title I will write for next class. That is very critical or very important or master example, something like that. Master class, etc. Something I will decide on attractive word I will use. I will tell go there, engineering mechanics, part 3, centroid, lecture number, I think most probably, I will make a note, 7, today 7, 8. Study that one and come back. Okay, now, next, see now, triangle is over, part 1, part 2, part 3. See, title I am writing, centroid for a triangle, part 3, and also centroid for trapezium. Now consider a trapezium. Centroid for a trapezium. This also will come next time. Centroid for trapezium. For a trapezium. For a trapezium. First, remember, you should know what is trapezium. Trapezium has 2 parallel sides. 4 sides are there. See, a trapezium can be either like this, see, this way, or it can be, 1 minute, I will start here. First, see, it can be this way, smaller, little big, and bigger this way, or it can be, these 2 projections are equal, see, this way, or it can even be this. I want parallel side, so I want parallel side here. See here, or it can be, see, this way, or it can be even, see, this way, or it can be even. That's all. Only 3 cases. Okay. Or it can be like which bigger, which never bother, which is bigger, which is smaller. It can be like this. See here, these 2 sides are parallel. These 2 sides are parallel. These 2 sides are parallel. Distance, the 2 parallel sides, I will call base. I will call one of them B1, other is B2. This B1, B2 is not your that triangle B1, B2 base. You can call this as base, this as base. This will become height, H. Height means distance between the parallel side. Or I can call this as B1, this as B2, this will become height. Here I can call this as B1, one of them B1, anyone, other B2, height h. Or it can be even like this also. See here, if I project here, these two are not equal. Here, symmetrical. These two are equal. Or here, two triangle and one, suppose you divide into parts, two triangle, one rectangle, two equal triangles and one rectangle. Here, one rectangle, one triangle. Or it can be even like this also, see. Bigger, smaller. Or it can be this way also. This all you are right. Or it can be like this also. Here, this side is parallel to this side. This side is parallel to this side. This side, it became same. Okay. I want, how I want? I want this way, see. I want these two parallel. Okay. What is there? I can make it. Okay. Once again, same. If I want these two parallel. Now correct. Okay. This way. This side is parallel to this side. Now, this will become base. I will call this as B1, this as B2. No, base is not horizontal. Between the two parallel sides, this is the height h. See here. I can call one of them B1, other as B2. This is h. I will call one of them B1. B1 is base. See, these are the base. This is the height h. You can call whatever way you want. So, there are three cases, so many cases are there. See, correct, clear. You make a note here. Here, now do one thing. You write one more sketch now. So understand, write a second round sketch. There, you divide into parts, just like that. See. Write one more round. Write one more round. Good for health. This way divide. I will tell you what is this one. See, a trapezium where if you divide into parts, see, this distance is not equal to this distance. Or that these two offsets are equal. This is symmetrical case. Or only one side projection is there. Any side. It can be this side also. B1, B2. Same thing here. These two are not equal. But then base is B1. These two are equal. It does not matter what way is the trapezium. Because now, after, don't cut it that way, you write a note there. Now, after all this one, what you write is, after all this statement, you write there. After all these sketches, you write trapezium. Standard expression, see, standard expression for locating centroid for a trapezium is when we consider centroidal distance from distances from any one of the base, that is along the height. Again, standard formula is along the height, or that height is nothing but distance, perpendicular distance between, distance means perpendicular distance, okay, perpendicular distance, understood, perpendicular distance between the parallel sides. Parallel sides. Parallel sides. Therefore, parallel sides are base. See, parallel sides we will call base and perpendicular distance between parallel sides, we will consider as height. Base in the standard formula, one of them B1, other is B2, and height we will always take H here. Later when you go to loading, symbol will change. Basic approach, remember this way. Okay, now make a note here. I will anyway, everything will once again come in the next class. So next class there is no proof, summary. It may run for more than 1.5 hours. Okay, now make a note. We have to locate centroid G. I already told you, G is located with view for the distance from either B1 orbit from the base or from the parallel sides and measured along the height. It can be this way or this way, does not matter. Height means distance between the parallel sides. We have two approaches. Option 1 by basic approach, that is integration principle, and option 2 easy method, that is summation, where we will divide the trapezium into a rectangle. Right here, where we'll divide the trapezium into a rectangle and either one or two right angle triangles. Depends. See, if it is this way, we will divide into a rectangle and two right angle triangle, whereas if it is this way, see, parallel side here, parallel side here. If it is this way, we will divide into a rectangle and one right angle triangle. It does not matter because in the expression that offset will not come. Only B1, B2 and H will come. So it does not matter whether there are, when you divide, whether you get a rectangle and two triangles, and also whether those two triangles are same or different, what areas or size, or you get rectangle with only one triangle, does not matter. One parallel side B1, other parallel side B2, you can call bases. Between the two parallel side, distance, height, you can go either by basic integration principle or summation. I will do both now, but do one thing, to save the time, I will prepare a sketch first and then go for it. Little, otherwise, time is consumed. Now start. Centroid G for a trapezium. Consider a trapezium of parallel sides B1 and B2. I call B1, B2 for here because they will become base. Okay. Anyone can be taken base. Time being, parallel sides are B1 and B2, and let H be the perpendicular distance between the parallel sides. Here, consider B1, B2 as the base. Anyone, both are bases, and H as the height. We will derive expression for distance of centroid G always along height. I told you, the formula, standard formula is always along the height, that is along H. Always along H. Measured from the base. See, this way or this way. See, height is here, we will derive here. Okay, then. As per the sketch, centroidal distance is y bar. From B1, we will consider from B1. See, once you get from B1, from this side, once you get this y bar, from other side it will be h minus y bar. Okay, any one you get. As per our sketch, it is y bar. Suppose you put trapezium this way, you have to call x bar. Okay. Y bar from B1, y bar from the base B1, or you can tell from AB. Option 1, use basic concept, that is integration principle right here. Basic concept. For that, consider elemental strip. See, elemental strip of thickness dy. I told already, if you want y bar, thickness should be dy. At y from, we want centroidal distance from AB, so you should take y from AB only, y from AB, this way. Okay. Let the width of strip equal to B dash, this width, and thickness equal to dy. And let the area of the elemental strip be dA. This all you know it. Now, you should get the value of B dash. See, for getting B dash, this is B1, this is B2, total is H here. You are moving by Y. As per the sketch, your width is decreasing. It can increase also. Then as per the sketch, B dash equal to B1 minus, Y minus, because as you go this way, it is decreasing. Suppose you put the trapezium by chance this way, you have to add plus there. Okay, B1 minus B2, B1 minus B2 divided by H into Y. Into Y. It is into Y. Okay. Into Y. This is the expression for your B dash. That is by linear interpolation class. Here I will not explain, because anybody who is studying structural engineering, he should know how to apply linear interpolation. It's a basic requirement. But I know so many people, what all I tell you, right? So many people are not knowing. For that purpose, you go to my channel. You know my channel, that is this channel only. KSN Structural Engineering Classes. Go to playlist. And then you search there. Little down you can see mathematical concepts. Mathematical concepts. I uploaded 3 classes so far. In the YouTube, you can see 3 videos. I never call my class as video. My class has got value. 3 classes. You can see there are 3 videos. There, class number 1, I think class number 1 is something else you require later. Class number 2 also, something else I will tell later. Go to class number 3. Class number 3, where you can see heading there, linear interpolation. I explained the concept there in such a crystal clear way that somebody walking in the road without any higher mathematics, some primary school or high school student, he will understand very thoroughly. He will understand. Even I have given a money matter example also. What principle it is done, I told some practical money matter example. You go to that class, thoroughly go through, write everything, you will become master in this linear interpolation. That's all. Further I will not tell. From engineering mechanics point of view, you are supposed to know this one. Okay, but still remember, you are supposed to know. Still I know the present trend of education and knowledge level. I have seen it. So many people who pass BE, even they have difficulty for this linear interpolation. So for them I uploaded there. Such a crystal clear way that I told you, somebody without any higher knowledge, even for example, high school student, he or she will understand with the crystal clear clarity after going to that class and studying it, if you ask the question, he will tell suddenly answer. Suppose some sketch you tell, what is this value? 15 minus 10 divided by 8 into x, subtract it from 8, 15. Or 15 minus 8 divided by 10 into x, add it to 8. Sometime he will tell add it, sometimes subtract. See, since you are going this way, it's decreasing, subtracting is there. If you come from that side, it is adding. That is your problem. Now, that much effort I put there, go through it. Okay, start, b dash over. Therefore, area of elemental strip dA equal to b dash into dy. So, dA will become, see here, b1 minus b2 by h into y, y is green color, into y, this full term into dy. That is the area. See, width of strip b dash is here, b dash into dy is the area. Now, therefore, now you know it, what to do. See, now you know correctly, because why? Very thoroughly I explained for you. Then y bar from where you are doing? We are doing from AB. Y bar from AB is equal to integration of dA into y divided by total area. Total area is nothing but integration of dA. Limit is our y will be varying from 0 to h, common sense. Y varies from black color, not green color. Y varies from 0 to h. 0 to h. 0 to h. This is the formula for y bar. This everybody is knowing. Therefore, okay, now I will consider one by one. This full I will remove. See how much I remove. This I see. This I require once again. So therefore, this I cannot remove. This I cannot remove. Okay, this. See, this much should be there. I cannot remove this one because it is required. So I will remove from here now. It is unwanted now. You go through it and understand. Okay, then all over now. Okay. Now consider numerator. Consider numerator. That is integration 0 to h of dA into y, or equal to integration 0 to h of dA is here b1 minus b2 divided by h into y This is your d into dy also is there. Sorry, into dy. I'll put a flower bracket. Okay, I'll put a mini bracket this way. See, this is into what? Into dy, then into y. Into y. Okay, sufficient. This I'll remove. Equal to integration 0 to h of, see here, b1 into y. b1 into y, one term, minus b1 minus b2 by h. b1 minus b2 by h into y is y square. See, earlier one class, by mistake, I put dy there into dy. Okay, that is into dy, sufficient. Okay, I will go for integration now. Very simple integration. This is not as complicated as your last time class. Simple. Or equal to, see here, b1 times y becomes y square by 2 0 to h minus b1 minus b2 by h into y square becomes y cube by 3, again 0 to h. That's all. Now green color will vanish. Why? No more integration now. No more dy all, or equal to, see here, equal to b1 into h0, h square by 2 minus 0 minus b1 minus b2 divided by h into y cube becomes h cube divided by 3 minus 0, or equal to bh square, b1, okay, equal to b1 into h square by 2 minus h cube by h is h square. So b1 minus b2 into h cube by h is h square by 3. Or if I take h square outside, I'll do one thing, I'll take, to make easier, h square, 3 and 2 are there, I will take 6 outside, common. Then 2 3 times, 3b1 minus bracket, h square by 3 minus 6, 3 2 times, 2b1 minus 2b2, or equal to h square by 6 times 3b1 minus 2b1 is, so much, 3b1 minus 2b1 is b1 minus of minus 2b2 is plus 2b2. This is your numerator. Okay, this is the numerator. Come to denominator. Now see, this I will remove now. I don't require etc. Area is here only. Anyway, I can make out the area is there. That much I can make out. Okay. Now denominator. Consider denominator. Consider denominator, which is A, that is area of trapezium. Area of trapezium. Actually, remember, there is a standard formula for area. I will tell you later. Anyway, right now, you know that area equal to integration of only dA. Okay, now green will come. Integration of only dA, that is nothing but integration 0 to h of dA is here. How much? b1 minus b2 divided by h into y, only dA, no dx, no into y, into y times dy. See there, I got earlier, or equal to, integrate now, equal to b1, it's a constant, nothing is there, into y, because y, when you integrate a constant, it becomes constant into y, limit 0 to h, minus b1 minus b2 divided by h into y, when you integrate, becomes y square by 2, again 0 to h, or equal to b1 into h minus 0 minus b1 minus b2 by h into h square by 2 minus 0, or here b1h minus h square by h is h minus b1 minus b2 times divided by 2 times, or I will divide by 2 times of h, b1 minus b2 by 2 times of h, or equal to, take 2 common denominator, Actually not, okay, take 2 half outside. Half, actually not half, you take h by 2 outside. If you take h by 2 outside, 2 times b1 minus b1 plus b2. 2 times b1 minus b1 minus or minus plus are equal to h by 2 into 2b1 minus b1 is b1. b1 plus b2. b1 plus b2. h by 2 into b1 plus b2 is denominator. Or you can do one thing now. I can remove or, because see, everything is over. To save the space, this I cannot remove. Okay, remember, your numerator is here, denominator is here, sufficient. Okay, now I will remove this one. Or you can do one thing. Or as per standard expression, directly area of a trapezium is, standard formula is there, is sum of the parallel sides divided by 2 multiplied by, this is a standard formula. This is actually a standard expression, standard, multiplied by perpendicular distance between parallel sides. If you use that way, then your area will become sum of the parallel sides, that is b1 plus b2 divided by 2 into distance between parallel side is h. Right? Oh, same answer we got even by integration. See here, b1 plus b2 divided by 2 into h. Same answer we got. It will come. Therefore, now closing part, how to get y bar. One minute. Some of the parallel, where I can remove now. This all is unwanted now. I can remove all this now. Everything I can remove. Okay. Everything I can remove. Because otherwise not required. Okay. Therefore, substitute now and get the answer. One minute. Let the board become little dry. Have patience in my class. This much effort I am putting, you should have little patience. You should not tell, we have to wait for, wait. I will tell sometime in the offline class, when I write something, some people, nobody will raise objection. Sometimes I may take rest. I will tell 5 minutes break. I may come after a little more than 5 minutes. No one will call me. Sometimes rarely it happened. Sir, 5 minutes over, one person told. If you tell 5 minutes over, I will take 5 hours. Don't tell me to come. I know. These things all I don't recommend. You study, you behave like a student. Okay, other things, if I teach wrong or miss the classes, then you can comment. That also I never do. Therefore, your y bar from AB line, see, from AB line we are doing, from AB or from B1 equal to, already over, integration of dA into y by total area is integration dA into y is here, h square by 6 times b1 plus 2b2 divided by area is h by 2 into b1 plus b2. Now, or therefore, your y bar from AB, that is, or you can tell from B1, from parallel side B1 equal to, see here, B1 plus 2B2. I start from there. B1 plus 2 times B2 divided by B1 plus B2 into h square by h is h. 2 will go to numerator, 2 by 6 is divided by 3. This is the expression for y bar for a trapezium from the parallel side B1. Tomorrow I will explain, next class I will explain this by, I will explain by words. Anyway, briefly I will tell. When you want to locate centroid for a trapezium from any one of the parallel sides, measurement is along the height or distance between the parallel sides. The formula is from where you measure that parallel side. Suppose you want from B1, that parallel side plus twice of other parallel side. See, if you want from here, this parallel side plus twice of other parallel side divided by sum of the two parallel sides multiplied by distance between the two parallel sides divided by 3. And I will tell area for trapezium is sum of the parallel sides divided by 2 into distance between the two parallel sides. This I got y bar. This I got y bar from what? From, this is y bar result from, this is result from integration. That is basic concept. Okay, now I will go for, see, I got y bar from AB. Other y bar I will do later. Now, see, now, I write here. Now, we will go for option 2. Option 2, where again we will find y bar. Again, we will find y bar. We will find y bar from AB only. From AB only. 100% same answer will come. My guarantee. But this time we will go for summation principle. Summation principle right here. That is, the given trapezium we will divide into rectangle and either one triangle or two triangle. You can make out one thing here. See, this projection has not come in calculation. See, now it does not matter how much is this one, how much is this one. It does not matter. It matters when you want this distance. That I will tell you later. Our standard formula is always along the height. So if you want from here, B1 plus 2B2 by B1 plus B2 h by 3. Suppose from here if you want, it is B2 plus 2B1 divided by B2 plus B1 into h by 3. What I will do is, I will get from summation theory same y bar. Once I get that one, then I will tell. Now for both by integration principle and also by summation, we got y bar from here. Now if you want y bar from there, what to do, I will tell you after I complete second option. For second option, sketches are there. I will prepare the sketches so that I can adjust the space. Little advantage for me, time saving. Now come to last closing part. See here, centroid of a trapezium. All statement you write up to here, you write here. Some space I require. I will remove the statement. See, this statement I will remove. I will remove the statement. Already over. How many times I have tell? This is already over. See, this is B1. Okay, B1. Now write option 2. Option 2 to get what? To get y bar from where? From AB only. To get y bar from AB only. From AB. AB means that is from B1. From B1. Some statement I will write here. You should write it. No space to write here. See. Some statement I will give you. We will divide this. See. Divide this trapezium. You write here, this is by summation, that is A1, Y1, A2, Y2, A3, Y3, etc. I will write here. We will divide this. See, some statement I will give you, space not there. we will clearly dictate. Let us divide the given trapezium into rectangle and, as per the sketch, two triangles. Therefore, see here, rectangle and two triangles as shown here. See, this way. Divide. I will call this as part 1, this as part, okay, this is second part, this is third part. Here, this is your B1, this full is this is your B2, okay, B2, full is B1. Now, there are two offsets here. It is possible that these two are equal or only one offset will come. See, if the trapezium is like this, only one side offset will come. It does not matter. In the expression just now we got only B1, B2 and H will come. Now, to understand, let us consider the two offsets are different. Some name. Let this left side offset be P, right side be Q. I first thought of taking B dash, B double dash. No dash. Some other symbol, PQ. This is P and Q. Remember, this is your B2. See, this is B2. This is B2 understood. B2. You take this way. Now, draw a neat sketch. See here. This is P. This P later will vanish. This Q also later will vanish. Okay. I will take this as P. This is B2 means this also B2. This is Q. Full is B1. Okay. H. Then Y bar from AB. See, because you are doing Y bar how? This way equal to A. Now your Y should be, see, when you take Y bar from AB this way, your Y should go this way. This way Y. Sorry. A1, Y1. Little cough. Okay. A1, Y1, A2, Y2, A3, Y3 by total area. Okay, start. Consider numerator. Now, before that one, see. Figure 1, figure 2, figure 3. This is centroid for figure 1, G1. See, this is base. This is height. From the base along the height, 1/3 of H. Triangle. This also. This is base, this is height. Along the height, 1/3 of H. From here. If you do from top, you are right, 2/3 of H. This is rectangle, exactly midpoint. If this is H, this will be H by 2. So, your numerator, A1, Y1, A2, Y2, A3, Y3 equal to area of figure number 1, half into P into H, half into P into H into Y1, 1/3 of H, plus this area is B2 into H rectangle into H by 2 plus once again half into Q into H, one more area into 1/3 of H. Simplify. You take, see, H into H, H square, H into H, H square, H into H, H square. Take H square outside. Here 3 into 2 is 6. Here 3 into 2 is 6. Here 2 is there. So take S square by 6 outside. It will become S square gone. 6 as this P plus H square gone. See, I have taken 6 outside. So this 2 is there. 2 3 times. 3 times B2, actually high school mathematics. 3 times B2 plus Q. Okay, this if I explain, someone will tell, sir, we are engineering students. We can make out that much. Okay, enjoy it. Or equal to H square by 6 into P plus 3B2 plus Q. You do one thing, you write P plus 3B2, you write B2 plus once again 2B2. Because P plus B2 plus Q is B1. So, you split this 3B2 as once B2 with P and Q, then separately write 2B2 or see P plus B2 plus Q plus 2B2 or P plus P plus B2 plus Q is B1. So it will become h square by 6 into B1 plus 2B2 is numerator. Okay, now come to denominator. I will remove this one to save the time. Okay, I want only numerator now. I can remove all this. I want only answer. Okay. Remember, this is our numerator. Come to denominator. Denominator is area equal to A1 plus A2 plus A3 or equal to half into P into H, this area, plus B2 into H, this area, plus half into Q into H, that area, or equal to, see, you can take here half, take half outside, half into H if you take outside, P plus 2B2 by half outside plus Q, or equal to half into H into P plus B2 plus Q plus once again B2. But remember, P plus B2 plus Q is equal to B1. Already I told you, P plus B2 plus Q is B1. Therefore, your area equal to H by 2 into B1 plus B2. Or, I already told you, directly area of trapezium equal to sum of the two parallel sides, that is B1 plus B2 divided by 2 into distance between them. Oh, same answer. See, B1 plus B2 into H by 2. Same answer. Over. Now, last step. Over. This class, I can remove everything now. Nothing required. Nothing required. You write everything fair copy. Therefore, your y bar from AB as per our sketch. From AB means, I told you repeatedly, that is from parallel side B1 equal to numerator, see, sigma A1 Y1 by A. Sigma A1 Y1 means A1 Y1, A2 Y2, A3 Y3 by total area is, numerator is h square by 6 into B1 plus 2B2 divided by area is B1 plus B2 into h by 2. H by 2. Therefore, y bar from AB, that is from where? From the parallel side B1 equal to, I told, see, you make a note here. This is y bar from AB. From AB. Okay. B1 equal to, see here, B1 plus twice of B2 divided by B1 plus B2 into h square by h is h. 2 will go to numerator. 2 by 6 is 3. Write the answer. And write here, yes. Same answer, same result. Just now, just little earlier, we got from integration principle also, that is option 1. Same answer came. Okay, now make a small note. Okay, small note. Now, see, you can see here, P and Q vanished. See, now, this way. Centroid is here. G. Suppose you want from, this is B2, this is B1, this is H. Suppose you want y bar from B2, from here, see, right here. Suppose you want this y bar. This is y bar from B2, B2, A, B, C, or from CD. See, this is AB, B2, or from CD, equal to, this is C, this is common for both options, because in both the options we got y bar from AB equal to H minus H. See here, this full is H. Whatever is H minus your y bar, H minus y bar from AB, equal to H minus y bar from AB, you got B1 plus 2B2 divided by B1 plus B2 into H by 3, or equal to H into 1 minus B1 plus B2, B1 plus 2B2, B1 plus 2B2 divided by B1 plus B2 into 1 by 3. Or if you take H divided by 3 into B1 plus B2 common, it is 1. So 3 into B1 plus B2, 3 B1 by 2 minus of B1 plus 2B2, or equal to H divided by 3 times of B1 plus B2 into 3B1 minus B1 is 2B1, and 3B2 minus 2B2 is plus B2. See, 3B1 minus B1 is 2B1, and 3B2 minus 2B2 is B2, or you can rewrite this as B2 plus 2B1 divided by B2 plus B1 into H by 3. 1 minute, camera checking. I think I have not gone below that line. They said bottom line is there. Yes, no problem. Over. Oh, this answer. Or I will conclude the class now by writing the final result. See here. Final result here. Or this all I am going to explain by words in the next class. Therefore, right here, if there is a trapezium where B1 and B2 are the two parallel sides. See, this is your B1, this is your B2, and H is the distance between the parallel sides. We are marking, you should write, we are locating centroid along the H, along B1 or B2. That is separate principle is there. That is there. This formula is not applicable because there is no parallel side here. We are locating centroid from one of the parallel sides, and measurement is along H. Centroid may be somewhere here. Which side bigger, I don't know. G. Here. If you want this distance, this is y bar from B1, or this distance is y bar. Here it is y bar. If you turn the sketch, it will become x bar. Y bar from B2. Y bar from B1 equal to, see, from here you are measuring this side first. B1 plus twice of other side, 2 times B2 divided by sum of the two sides, B1 plus B2 into distance between the parallel sides, H divided by 3, and this will be equal to, there is no space to write here, I write here, equal to, if you want from here, see, start this side first. See the answer, B2 plus 2 times B1, this side plus twice of other parallel side, divided by sum of the parallel side, you can write b1, b2 plus b1 plus b2 only, but write b2 plus b1 into distance between the parallel side h divided by 3 is our final result we got today. This everything I will explain thoroughly with words next class, and then next class I will also tell you how to locate this distance. That is, you have to do by part. That I will cover next class. So today's class I will wind up now, and remember tomorrow's class or next class, okay, next class is the very power very important people who want to understand, because I am giving summary of centroid for all three cases of triangles and trapezium, different orientation. If it is this way, if it is this way, everything I will tell, and then I will extend it further for load calculation. See, when you got uniformly varying load represented by a triangle or trapezium, already over earlier I told at that time all these things, but now you know the answer. So with the concept I will tell what we have done earlier. It will become more clear for you, or it will be firmly, you will have very firm grip for uniformly varying load represented by either by triangle or by trapezium. Which triangle? Any triangle. Either triangle in general, or isosceles triangle, or right angle triangle, or trapezium. That everything next class. Suppose the class is too long, I may do in two parts. One part for triangle, I will tell very important concept class 1, very important concept class 2. Depends on how much time I require. Before that, I will explain all the centroid formula what you got by words, full board, sketch after sketch. I will explain, go through and understand. Okay, thank you.